everyone. You might have noticed that when we solve Pythagorean theorem problems or special right triangle problems, we are often working with square roots. In section 3, we are going to talk about operations with square roots. First, we have a bit of square root notation. The symbol that looks like a check mark is called the radical symbol. The number inside the radical symbol is called the radicand, and the number in front of the radical symbol is called the coefficient. Here's the product rule. If a and b are non-negative, the product of the square root of a and the square root of b equals the square root of the product of a and b. So we have the square root of a multiplied by the square root of b equals the square root of a multiplied by b. Here's an example. The square root of 3 multiplied by the square root of 7 is equal to the square root of 21. Now let's talk about simplifying square roots. To simplify a square root, factor perfect squares out of the radicand. When a square root is simplified, the radicand has no perfect square factors. So what's a square factor? Well, 100 is an example of a square factor. 100 is 10 squared, and we know that 200 is 100 multiplied by 2. So the square root of 200 is equal to the square root of 100 multiplied by the square root of 2. So that's equal to 10 root 2. And now we have simplified the radical. The square root of 150, we can simplify that by factoring 150 as 25 multiplied by 6. So that gives us 5 root 6 because the square root of 25 is 5. And now we have a simplified radical. The square root of 72, well, 72 has a perfect square factor of 36, so we can rewrite that as the square root of 36 multiplied by the square root of 2. So we get 6 root 2. Now let's talk about multiplying square roots. When we multiply square roots, we multiply the coefficients and multiply the radicands, and then simplify. So here we have 5 multiplied by root 3 multiplied by 4 multiplied by root 3. So using the commutative and associative properties of multiplication, we could think about this as 5 multiplied by 4 multiplied by root 3 multiplied by root 3, and that gives us 20 multiplied by root 9. We get 20 from multiplying 5 by 4 and root 9 by multiplying root 3 by root 3. Well, we know that the square root of 9 is 3, so this gives us 20 multiplied by 3, which is 60. In our next example, we have 10 multiplied by 7 root 2. Well, we're just going to multiply 10 and 7 to get 70 root 2. And then finally, here we have 6 root 2 multiplied by 3 root 8. And this is equivalent to 6 multiplied by 3 multiplied by root 2 multiplied by root 8. So that gives us 18 root 16. And the square root of 16 is 4. 18 multiplied by 4 is 72. Here's the quotient rule. If a and b are positive, the quotient of the square root of a and the square root of b equals the square root of the quotient of a and b. So here we have the square root of a divided by the square root of b, and that equals the square root of a over b. Here's an example. The square root of 21 divided by the square root of 3 is equal to the square root of 21 over 3, which is equal to the square root of 7. Now let's talk about dividing square roots. To do this, we divide the coefficients and divide the radicands, and then simplify. Here's an example. 6 root 30 divided by 2 root 3. we're going to divide 6 by 2 and then divide root 30 by root 3, applying the quotient rule. This gives us 3 root 10. Here, we're going to have 10 divided by 1 multiplied by root 75 divided by root 5. And that gives us 10 root 15. Here we have the square root of 32 divided by 2 root 2. So this is going to give us the square root of 32 divided by root 2, which is the square root of 16 divided by 2. And that gives us 4 over 2, which is equal to 2. And finally, we have rationalizing the denominator. We're going to multiply by 1, and we'll do this by multiplying the numerator and denominator by the radical in the denominator. So for example, here we have 21 over the square root of 3. So we're going to multiply by the square root of 3 over the square root of 3, which gives us 21 root 3 over 3. Then when we divide 21 by 3, we get 7 root 3. Next, we have 125 divided by the square root of 5. If we multiply by the square root of 5 over the square root of 5, we get 5 in the denominator and 125 root 5 in the numerator. Then dividing 125 by 5 gives us 25 root 5. Finally, we have 44 over root 2. If we multiply by root 2 over root 2, that gives us 44 root 2 over 2. And then dividing gives us 22 root 2.